a how-gow, where each freshman engineering students here at UMass Lowell, and our proposal is the iHand prosthesis. So the real problem that we're trying to address here is the fact that sub-forearm prosthetics are simply too expensive to the average consumer today. They're really limited in options. The ones on the lower cost end of the spectrum are often too limited in their functionality, and the ones on the higher end are too expensive, simply speaking. They can be very stress intensive on the user, and as such there's really this low motivation to go about attaining them. As a matter of fact, we each have a friend from our hometown who lost the majority of his left hand in a car accident several years ago. And as a result, he didn't see the appeal to pursuing a low-cost prosthetic because it wasn't enough functionality for his needs, and he didn't exactly have the budget to pursue something on the other end of the spectrum. And so that's where a large portion of the motivation for this project has come from. So our opportunity here lies in 2009, there was roughly $8.3 billion spent in total amputation costs worldwide. In the United States alone, there are 2 million individuals suffering from limb loss, both upper and lower extremities, and there are currently 185,000 additional amputations occurring every year. Of these numbers, roughly 10% of them pertain to upper extremities, whether it be full arm, partial, or hand. So the main industry leader for the moment is RSL Steeper with their B-Bionic 3 arm. The arm offers a lot of functionality while giving a very high price tag to the user. It would be $30,000 per unit, which in return for an arm, I suppose, is well worth it. However, if you do not have these funds, there's simply no way to go about it. The myoelectronic technology that they use actually functions off of electrical impulses sent through the remaining muscles in your arm to translate into mechanical energy. Our solution is to integrate eye tracking technology into the current forearm prosthetics. We seek to start from a low member of functionality, starting with finger movements, opening and closing of the palm, pinch grips, really the fundamentals needed, which each correspond to a specific retinal sensor along the forearm itself. So when the user looks at these sensors, it sends a yes signal throughout the prosthetic, and as such, tells the hand to repeat a specific motion, which corresponds to that sensor, over and over again until the user looks away. The way that pressure is addressed here is very similar to the myoelectric units, in which there are pressure sensors along the fingers, which prevent too much squeezing, too little, things of that nature. So these are really the available technology today. That is the Tobii iX sensor, which markets for about $140 US. Utilizing their equipment in households, which is shown by Steve Murray, who is a former BMX rider. Suffered a spinal cord injury, and as a result, Tobii came in, implemented these sensors inside their household, and as such, he gained a lot of freedoms that he wouldn't have previously had without their help. The resources we need to go through this project really start with intellectuals. We need to broaden our group. We're only a mechanical engineering major, a chemical engineering major. We need business majors, computer science, programmers, things of that nature. Those are all things we're hoping to get from UMass Lowell as a result of the interest sparked in our project through this presentation. In addition, the finish the start funding would go towards the production of a more detailed design of the concept, as well as prototyping over the next several years as we operate in junction with UMass Lowell Biomedical, as well as with Tobii Technology in the UK. Thank you.